Okay, so this is question 15. A software company needs to raise money to expand. It issues a 12-year bond of €1,500. That means you're going to get €1,500 in 12 years' time. That pays €50 at the end of every 6-month period for 12 years. If the current market annual EAR is 6.75% with interest added at 6-month intervals, what is the fair market value of the bonds? Okay, so what we're going to do here is we're going to get f equals 1 plus I to the power t. In this case, p therefore is equal to f over equals f over 1 plus I to the power t. F value is 1500 and the interest value is going to be 1 plus 6.75, which is 1.0675. That's the power of 12. You put that into the calculator and we get 684.98. Now, once we have this section done, which we do, what we got to do next is we got to find out what is the current value of our €50 payments. Okay, so what happens is we're going to use a monthly rate for a start, okay, or not a monthly rate, a half a year rate. So usually we'd do 1 plus I to the power of 12 if it's monthly, but it's not monthly, it's every 6-month period. So this means we're only going to use there's only 2 payments a year, okay, and that's going to have to be the equivalent of 1.0675, okay. Our B value therefore is going to be 1 plus I, which is equal to the square root of 1.0675. Okay, so it's going to be equal to the square root of 1.0675. Now, our B value, square root of 1.0675, shift star B. Okay, there's our B value. Now, we have to find out the current cost. Now the current cost is, if you look at this and you go, okay, from now in 6 months time I get €50. So it's going to be €50 divided by b to the power of 1, because we want to find out what value is it today. So look, for instance, €50 divided by b will get me €48.39. So €50 in 6 months time is the same thing as €48.39 today. Likewise, the second payment in a year's time. Now remember, the 1 represents 6 months and the 2 will represent 12 months, purely because we're using this interest system here. Okay, so then it's b to the power 2, so you can say 50 divided by b2, b squared even. That means that in a year's time, if I give you €50, that €50 is worth €46.84 today. Now we can see that this is a geometric sequence. The next one's going to be B3, and then all the way to the last one. Now, how long is the last one away? The last one occurs at the end of 12 years, and the end of 12 years will mean 50 over B24. Okay, because it's 24 months. It's 12 years away, okay, which is 24 half years, okay. So this represents 12 years, or 24, 12 years, okay, or 144 months. Now, what we have here is a sequence, or Sn equals a into 1 minus r to the power of n all over 1 minus r. Our a value, or our small a value, is 50 over b. Our r value is getting multiplied by 1 over b each time. So we're going to save 1 over b as the letter c. So we can just do 1 divided by b. Then we can store that as the letter c. Okay? Now all of a sudden our equation becomes 50 divided by b, 1 minus c, because r is c. Now n is the number of payments. You're going to make 24 payments in total, because it's it's 12 multiplied by 2 payments a year, which is 24. So it's going to be c to the power 24 all over 1 minus c. So we put that into the calculator, and what we get is 50 over b bracket 1 minus c to the power 24 all over 1 minus c, and that will get you is 818.32. 818.32. Now, this 818.32 is the current value of all your €50 payments. And we got to add that onto 684.98. So we add it onto 684.98. What we get is we're going to get 1,503.30.